Hello and good morning everyone. I'm Mr. On, and in this tutorial video I'll go through some qualitative analysis which is to test for anions. So what I'm going to show you today has to do with something called ammonium ions. So ammonium ions is NH4+. If I just show you on the screen, that is NH4+, like that. So what we have NH4+, it is not an ammonia molecule, it's a cation. So it's a result of ammonia having obtained a H+, and therefore it forms an ammonium ion. So this is NH4+. A lot of ammonium compounds are known. So ammonium compounds are very common in fertilizers as a source of nitrogen. But typically we are looking for nitrate as the main source of nitrogen that results in the the environmental effect, which is the eutrophication. I've just given you I have here a couple of ammonium salts. So I just want to show you what they look like. Okay. So in my other tutorial video the other day, when I make up a stock solutions, I have a 250 ml solution of ammonium nitrate, so the concentration of which I have forgotten, but I have made up a solution of ammonium nitrate that is NH4 plus NO3 minus. So you have NO3 minus such as this. So what you have then is you only need one of each, and then you get the salt as NH4NO3. Ammonium nitrate is going to be a very special analysis that we will talk about today, because it contains two species that has nitrogen. One of them is the cationic ammonium ion, and the other one is the anionic nitrate NO3 minus ion. Both of them in their qualitative analysis test give you ammonia gas, and that's why I find it to be a very interesting problem to discuss today. On the other hand, in case you have forgotten, so this is ammonium chloride, NH4Cl. That is just the molecular mass, the MR, that you can calculate using the relative atomic masses in the periodic table. So as you could see, they are very white solid. Okay, so all the ammonium salts are white, except when they are mixed with a transition metal salt. So ammonium salts are all soluble in water. All ammonium salts are soluble in water, just like all sodium salts, all potassium salts, all nitrate salts, they are all soluble in water. So that was ammonium chloride. Next up we have this ammonium carbonate. So this is straight from a 1 kilogram bottle, whatever we call it, container. Again, it is a white powder. So being an ammonium salt, this is an ammonium carbonate. So it's NH4 plus CO3 minus. So the formula ammonium carbonate will be NH4 plus CO3 2 minus. When you look at the respective ions, so you have NH4 plus and CO3 2 minus. So therefore you need 2 of the NH4 plus and 1 of the CO3 2 minus, because the LCM of 1 electron being lost from the NH4 and 2 electrons being gained from the CO3, the LCM, the lowest common multiple, and this was called lowest common multiple when I did it in primary school many years ago, is 2, and therefore we need 2 of the ammonium ions and 1 of the carbonate. So the formula for ammonium carbonate is going to be NH4 bracket twice meaning 2, and then 1 of the CO3. So this is ammonium carbonate. It is a white solid again. Being an ammonium salt, they will all be soluble in water. It's one of the ions that I will test in a little bit. Next up, I have ammonium ferrous sulfate. This is a very interesting one. If you look at the formula, this is what we call a double salt, because, surprise, when I show you, you see the color is a little bit greenish. That is not because the ammonium salt is green. The ammonium salts are always white, but this is actually 2 salts combined into 1. This is often called a double salt. Double because it consists of two different salts. The first one is ammonium sulfate, so NH4 plus SO4 2 minus. So NH4 plus SO4 2 minus, means that you need 2 of the NH4 and 1 of the sulfate, such that you get this formula for ammonium sulfate. Alright, so if there's the formula for ammonium sulfate, I also have ferrous sulfate. If you look at the name, ferrous reminds you of iron. The chemical symbol for iron in the periodic table is Fe. It's actually the old name for ferrous. Okay, so you see there is iron 2 sulfate. Iron 2 meaning Fe2 plus cation. Sulfate is SO4 2 minus anion. Because of the 2 plus and the 2 minus, the charge itself will be FeSO4. Or I mean the formula itself will be FeSO4 because the formula will have no overall charge. So together, if you have 2 of the salt combined together, what you're going to get is you're going to get NH4 twice, Fe, and then SO4 3 times. You can imagine that the sulfate, there are 3 of them, and then iron, there's 1 of them, and ammonium, there's 2 of them. Overall, the formula looks complicated, but it's actually a mixture of 2 salts, of which the ammonium sulfate is white in color. The iron 2 sulfate is the one responsible for the color, because transition metal forms colored compounds, as you would know from their chemistry. Okay, so this is something that we'll analyze as well today as part of our in-depth analysis into ammonium ion. So of course, what I've talked about is ammonium chloride, ammonium carbonate, as well as ferrous ammonium sulfate. So we have different anions, the first one being chloride, the second one being carbonate, the third one being the sulfate, in their respective order. So I'm more interested in the cations in this particular video tutorials, but I'll have other qualitative analysis video where I talk in depth about the test for the anions. Okay, so just as usual, in a practical setting or in an alternative to practical setting, you'll be expected to know the test for cations and the test for anions. So the test for NH4 plus, okay, so you need to test for NH4 plus. So because we're interested in the cations, is you will need to add NaOH. So you need to add aqueous sodium hydroxide. Aqueous sodium hydroxide is provided as part of the full list of reagents. So this is aqueous NaOH. They don't provide you the molarity, but it's typically around 1 to 2 molar. So it's a colorless solution, and in the presence of ammonium ion, it will not do anything until you heat it. Okay, so that's what I'm going to do today. I'll start off with what should I do? So I have my ammonium chloride solution, but I have my ammonium carbonate solid, and I have my ferrous ammonium sulfate. Okay, so what I'll do is probably I'll scoop a little bit of the solid. So this is ammonium carbonate. So obviously in an exam setting, they'll provide you in small vials, a little bit of the solid, or they might already make up the solution for you. But you can never discount the fact that they can give you the solid and they expect you to test for the solid. So before you test for anything, you have to dissolve it in distilled water. So the reason for using distilled water instead of tap water or deionized water is because distilled or deionized water has no other dissolved ions. You are testing for cations and anions. If you want to use tap water will have other dissolved ions that can interfere, that can result in an inaccurate qualitative analysis, whereas distilled or deionized water just have pure water that has been distilled out, no other dissolved ions. This thing is really, really hard. I don't need a lot of the solid actually, so I have a spoonful, which is probably enough. So sometimes you need to do 2 or 3 tests, so I will just make out a couple of, it's probably a little bit in there, doesn't matter, I just need a little bit for our test. And I did not have my distilled water, so just give me a minute. Oops. So this is my distilled water. So what I'm going to do is I will have it dissolved in a little bit of distilled water. So this was ammonium carbonate. Ammonium carbonate, all ammonium salts should be soluble in water. In fact, you can see they are starting to dissolve already. Probably not everything, but I'm gonna try and swirl it so that they all dissolve. There's a big chunk of the solid at the bottom. That was because I added in a bit of the solid, so I'll try and break up the solid, and they should all dissolve because all ammonium salts are definitely soluble in water. So test tubes are very fragile, so I really shouldn't be using a spatula in a test tube, okay? Because they're very fragile stuff. But as you can see, they're all pretty much soluble, so I'm not sure if the focus is going alright. But I can assure you it's all gone into solution. So this is ammonium carbonate. So let me test for ammonium carbonate. So the test for ammonium carbonate, you have to test for cations as well as anion. So what we do for the cation, which is the main test, is add aqueous sodium hydroxide and then we heat it. Okay, so add aqueous sodium hydroxide and then you heat it. So that is your test, but what will you observe? Alright, so those are your tests. And what will you observe? Well, let's see. Okay, so ideally speaking, I want to test for the anion as well, which is carbonate. So I will split the solution into 2 bits. Oops. So I'll try and split them into equal amounts because I'm going to do one test for the cation and one test for the anion. This was ammonium carbonate. So I have my Bunsen burner here. So I'm just checking if it's got gas inside. I've got my lighter here. And I have here some litmus paper because we are going to be producing ammonia gas. When sodium hydroxide reacts with ammonium ion, there's actually a reaction that's happening, but it's not actually part of your observation. Let me write the equation for you first. So NH4 plus reacting with OH minus will give you NH3 plus H2O. So I'm writing on my screen. This is usually what happens when I do my tutorials. I don't look at the video game, I look at my screen instead. So you can probably see and relate how I do my tutorials usually when you don't see my face at all. So this is an ionic equation. NH4 plus the OH minus giving you the NH3 and the H2O. The NH3 being a gas, being a molecule, and H2O being a molecule as well, liquid, so they don't dissociate into ions, and that's why the two ions just come together. And the OH minus, the hydroxide, will take away the H plus from the NH4 plus. The NH4 plus is giving away the H plus. The NH4 plus is giving away the H plus. So the NH4 plus is what you call the H plus donor. When a substance donates H plus, it is what you call an acid, and the OH minus is the H plus acceptor. So that is what you call a base. So this is an acid-base reaction. This is actually a neutralization reaction. You're producing H2O, but you're also kicking out NH3 because you are displacing the H plus from the ammonium ion. This ionic equation applies to every single ammonium ion reaction with sodium hydroxide or calcium hydroxide or any sort of hydroxide, because if you look at the equation again, it is not generalized to just sodium hydroxide. It is, however, generalized to any hydroxide, any species that can give you OH minus in solution. You add it to something that contains ammonium ion, and then you heat it, you will get ammonia gas, which you need to test for the gas, because ammonia gas is a colorless gas, so you cannot observe colorless gas. What you observe, however, is a test that confirms that this gas is ammonia. Alright, so I'm going to heat it now. In fact, before I heat it, I should add some sodium hydroxide. So this was the solution, ammonium carbonate. So I'm testing for the cations. So when I have that much solution, I should add that much sodium hydroxide. So it's usually an equal amount of sodium hydroxide. So far, there really isn't any changes. There are no precipitate, no whatever. You should add it drop by drop, but I'm already seeing no changes. So I want to add it to my finger height there. Just now the solution was there, so we add around the equal amount of solution. As you could see, it is still colorless. So when you add aqueous sodium hydroxide, there is no observable change until until you heat it. Until you heat it, you could smell it, and you wouldn't smell the pungent gas, even though you expect ammonia to be produced. But that reaction requires a bit of heating, because as you know, reaction has activation energy. Some reactions, when you mix them together, they don't react straight away. You need to provide a little bit of energy to kickstart the reaction. That is called activation energy. So hold it with a test tube holder. Okay, so it's a wooden apparatus, test tube holder. I'm not sure if this is a good idea. I'm sitting in the direction of the aircon. So be very careful when you're dealing with Bunsen burner. So make sure that when you start your Bunsen burner, the hole is always closed, because you want to ensure that the flame you get first is an orange colored flame. If it is straight away a blue flame, it's very hot, it's very dangerous, you can't see it. So you need to close the air hole to make sure that it's a yellow flame when you first ignite or when you first light up the Bunsen burner. That thing is not working. Yeah, it's got gas inside. Okay, so the fire has light up. As you can see, there's a little bit of wind there because of the aircon. I'll try and be very careful. I have taken away all any alcoholic solvent, so any alcohols has to be taken away from a naked flame. None of these solids are flammable, so I'm alright. Flammable meaning they catch on fire easily. So I have my red litmus paper, because we are testing for alkaline solution here. Testing for alkaline gas or alkaline solution, we use red litmus paper. You have got to make sure that you have got a bit of water, so moist. You got to moisten it, you got to dampen it. Okay. So they always say use a moist or a damp red litmus paper. So what I've done is I put a little bit of distilled water at the end of the litmus paper. So I am right-handed, so I will try and heat this in such a way. Oops, that is not good. And I'm back. So accidents happen, and one of the things that is very dangerous is making sure that your test tube holders are actually strong enough to support and can take up your test tube tightly. So the one that I had, I should have been more careful, because it was pretty loose around the end. So whenever you hold it, it seems like you have to tighten it, so it's not very stable. This one is a very stable one. So this wooden test tube holder is a really good one. So it was my bad. I should have checked it, and next time you know it, then you should have checked yours as well before you start any holding up your test tubes and doing heating and a bit of dangerous stuff. So I ran out of that first portion of that ammonium carbonate solution. So I'm just going to add a bit more solid in here, which is alright. Doesn't matter. Okay, so it doesn't take too long to make up the solution. And I just need to make sure that they're completely dissolved before I do any reactions. So I have the same problem as just now. There's a big lump at the bottom. So a lot of times you'll be provided solution instead that your lab technicians in school would have prepared a solution in advance. So you'll be getting solution rather than solid. Anyway, so that is the ammonium carbonate solution again. So it's colorless solution, completely dissolved. And I'm ready to heat up my solution now. So close the air hole. So there's the yellow flame, there's the blue flame. This is my red litmus paper, so it's a bit moistened at the end. So heat it. So when you heat it, let me just adjust the camera a little bit. So when you heat it, make sure you are not pointing the test tube to yourself. There's a bit of bubbles now, so make sure you don't just heat it in one place. Make sure you hold it and swirl it a little bit. And you can see the bubbles given off because there's a gas being given off. So what I do is I put my red litmus paper on top there. Do not touch the side. So you could see my red litmus paper has turned blue. You do not want to touch the side because you have just added sodium hydroxide on the side. Of course, in the presence of sodium hydroxide, this will turn blue. So you want to capture the gas at the mouth of the test tube. You do not want to test for sodium hydroxide. That is my point. You want to test for the gas, you do not want to test for sodium hydroxide. So what we are saying is you get a little bit of bubbles because there are gases given off. So it doesn't require you to boil it entirely. There's a little bit of gas being given out. You can smell it. The gas smells really pungent. It smells like your urine because ammonia is a gas that is produced when you urinate. Okay, so that's how your body breaks down nitrogen in your food, and because that's the important process. Okay, it's part of biological cycle for your body to produce urea, urea. That will break down on its own into ammonia. That's why your urine smells like ammonia when you go to the toilet, and that's why like this thing smells a bit like the toilet, you know, when you pee or whatever. Okay, so there's a gas being given out. The gas is pungent. We are testing for the gas, not touching the side because we do not want to test for sodium hydroxide, which obviously will turn red litmus paper blue because it's an alkaline solution, but we want to test for the alkaline gas. So really speaking, we were testing for the gas. So the gas is alkaline. So I can write my observation. A pungent gas is produced. Pungent, P-U-N-G-E-N-T, is formed or is produced, whichever one you like. And then of course we need to say the test. It turns, oops, I can't even write properly. Sorry if I'm not looking on the screen because I'm looking on my paper, well, on my screen paper. So it turns red litmus paper blue. So the gas is ammonia, NH3 gas, and you don't usually get it until you actually heat up the solution, because that reaction requires a bit of energy to kickstart. It doesn't take a large amount of energy, just a little bit of heating. Test for the gas, smell it, then the smell is not the actual test. The test is with the red litmus paper, and it turns red litmus paper blue, and it confirms that the gas is ammonia. You get ammonia gas because you have ammonium ion, so be very careful. The test is this reaction here, and this reaction here. If you get ammonia, that's because you started to have ammonium ion that can react with hydroxide. Okay, so that was the test for the ammonium ion. I will very quickly just test for the carbonate ion. So this is the other portion, the one that I didn't break earlier. To test for carbonate ion, CO3 2-, you just add a little bit of acid. So the only acid I have here is dilute nitric acid. I hope it is clear. I hope you can see what's going on. Ideally speaking, you should be doing this on your table, but I just want to show you what happened. You see effervescence because you see the rapid bubbling. You see the bubbles because there's a lot of gases being formed. This is what you see. You see bubbles. Okay, you see bubbles. When you see bubbles, you should be testing for the gas. And I have gotten the wrong size one. So this is like gas delivery tube. So this thing is supposed to stopper the gas, and this other end is supposed to go into a test tube containing lime water. So lime water is the test for carbon dioxide gas that's being produced. So I should have used a boiling tube which has a bigger inlet, and then I would close it up so that the gas doesn't escape to the atmosphere. It will be delivered through this glass tube into another test tube, and this test tube is supposed to have lime water. So I will bubble the gas through lime water, and it will turn lime water milky. Okay, so I haven't really done that here, but whenever you have a solution and then you add acid to it, or acid plus a solid or acid plus a solution, the acid will react with the solution, meaning to say the solution must contain carbonate. Okay, but if it is a solid, it could be a metal, because metal could react with acid to give you a hydrogen gas. So hydrogen gas has a different test. Carbon dioxide gas has a different test. We are testing for carbonate, so you need to add acid, dilute hydrochloric acid, dilute nitric acid, dilute sulfuric acid. Any acid will react with carbonate to give you carbon dioxide gas, but carbon dioxide is colorless. You see effervescence, there is your observation. You test for the gas by bubbling the gas through lime water. Lime water is also provided in your exam. Lime water is actually, where is my lime water? Lime water is actually Lime water is actually calcium hydroxide. So making out lime water, as you could see at the bottom there, there's a bit of white precipitate already, because lime water is actually saturated calcium hydroxide. So Ca2 plus OH minus, CaOH twice. Saturated calcium hydroxide, when the water gets out, the saturated solution will start to precipitate out. So calcium hydroxide being a group 2 hydroxide, the earlier the group 2 hydroxide is, the less soluble they are. So preparation of calcium hydroxide, which is saturated calcium hydroxide, for your lime water in the lab has a very specific preparation, because it's not like this where they remain completely soluble. For calcium hydroxide, you actually need to filter off the solid that does not dissolve. Okay, so this is actually part of something that has been asked in experimental planning, experimental design kind of question, not just in O-level alternative to practical, but also in an A-level alternative to, not alternative, in an A-level experimental planning, experimental design, and I'll share with you. Actually, I think the tutorial video is already up. It's a November 2020 paper 5.1, if I'm not mistaken, or paper 5.2, where the student has been asked to make up a calcium hydroxide stock solution, right? Anyway, so I already tested for the ammonium ion in ammonium carbonate. Now I want to test for this thing, the double salt. I'll leave the ammonium nitrate for the last one, because, no, actually I'll do the ammonium nitrate first. So this is ammonium nitrate. It's got NH4 plus and NO3 minus. I made up that stock solution as part of my other tutorial video on the experimental series. So we're going to test for ammonium nitrate. So we know that the test for ammonium ion is to add sodium hydroxide, and then we heat it. Okay. So the test for ammonium ion is add aqueous NaOH, and then you heat it, and then you get ammonia gas. The test for nitrate, NO3 minus, as you would have known it, is to add aluminium. So we have some aluminium foil here. So this is aluminium foil. So you have provided a small piece of aluminium foil, and then we add NaOH aqueous, and then we heat it, and then we get ammonia gas. So this is why this question is very tricky, because just because you get ammonia gas, how can you ensure that the ammonia gas that you get is from the ammonium ion versus the one from nitrate ion? So as you can see, the main difference here really is adding the aluminium foil. So that's the main difference there. So for the nitrate ion, to test for nitrate ion, without the aluminium foil, it does not give you the ammonia gas. But for the ammonium ion, without the aluminium foil, it already gives you the ammonia gas. As you remember, I shouldn't really be holding my screen like this. I should really have just do it side by side, but I'm a bit short on time. As you know, these are done during my free time. So if you enjoy my videos, don't forget to subscribe, click the button on the bottom right, and please share the channel widely with all the O-level, the IGCSE, the A-level learners, because these are practical skills, and they are the same skills that will be useful at whatever stage of your curriculum. Okay, so thank you for sharing, and don't forget to follow me at ptet.chemistry on Facebook, Instagram, and Twitter. Once you're back on these platforms, probably when exams are over, I guess. But anyway, I mean, yeah, do leave comments on those social media platforms, or simply on the YouTube video, and let me know what you think about my tutorials. So far, it's been mostly positive. Obviously, I can't satisfy everyone, and my time is limited, so I can't really do more and more, because I've got my daytime job, my other responsibility to my daytime job, as well as my own students. Anyway, so now it's school holidays, so I get a bit more time to explore things. So yeah, so which test should I do first? Should I test for nitrate or should I test for ammonium first? If you look carefully, both of them require the addition of sodium hydroxide. So this really tests students' logical understanding. If I add aqueous sodium hydroxide, what do I get? If I just add sodium hydroxide and I heat it, I get ammonia. It must not come from nitrate, Because for the nitrate identification, I need aluminium foil. So the first thing you must realize is I must not add aluminium foil first. If I add aluminium foil first, then whatever ammonia I get, could it be from the ammonium because I have sodium hydroxide? Remember, you also have to add sodium hydroxide when you test for nitrate ion. So really, I should leave the aluminium foil thing, which is to test for nitrate, as my second step. I must test for ammonium ion first. That is the logical thing, because once I add aluminium foil, then the ammonia that you get could have been from the ammonium ion, or it could have been from the nitrate ion. But you want to identify clearly that this ion is present and then that ion is present. So the logical thing is to identify NH4 plus first. So we identify NH4 plus first, and then NO3 minus. Okay. If you want to identify NH4 plus first, that means you don't add the aluminium foil. Actually, before I do that, I should really take out my solution first. I'm just worried that it's not concentrated enough. So ideally, I have the solution ready, but I think for this particular purpose, I'll probably just make up a little bit more of the solution, because I know I can make them to be more concentrated. And I forgot where I have my ammonium chloride. So this is ammonium chloride. I'll just make up a little bit more of the solution. Like I said, because I'm worried that I forgot what concentration was my solution the other day. Okay, so this is ammonium chloride. Oops. Here I'm not so interested in the anions, but of course in the real exam they will be very interested in you testing for the chloride. So to test for the chloride, you need to use silver nitrate, acidified silver nitrate. So now this is completely soluble, so no more solid. Okay, well, if I stir it a little bit more, there will be no more solid. I put it into two portions. Let me just test for nitrate. Let me just test for. Oh wait, hang on. This is ammonium chloride. So this doesn't make sense. No, sorry. These two are ammonium chloride. Ammonium chloride. So I must not confuse myself. I said I wanted to test for ammonium nitrate. This is ammonium nitrate. So I will test for ammonium nitrate first. Ammonium nitrate. Okay. So I have got to use this stock solution. Okay. So let's see if it works or not. So ammonium nitrate solution, I will test for ammonium ion first. So I need to get out my red litmus paper. And don't forget that you won't get ammonia gas unless you add sodium hydroxide. So this is a good test tube holder. I will add my sodium hydroxide now. So we know that here there's only ammonium ions. So unlike the double salt, the ammonium ions doesn't do anything on its own with sodium hydroxide. Because I've got this much solution, ideally I should be using half of it. Then I don't need that much sodium hydroxide, because you do not want your solution to be too full. Because when the solution is too full, when you heat it, you run the risk of bumping it. Bumping it meaning when you hit it sideways, you see how the volume has gone higher on the side. When you bump it, it's very dangerous to the people next to you as well as yourself. Although you should know that you never ever point the direction of a test tube that you are hitting to yourself or to other people, right? So I'll close my Bunsen burner air hole. So we need to test for ammonium ion. So this is my red litmus paper. I moisten it a little bit. Okay. So make sure it's clean. Oops. That's alright. Okay, so now I want my blue flame to start heating. So make sure that your solution was mixed well. So again, you do not want to test for the sodium hydroxide, so do not let it touch the site where you might have sodium hydroxide on the side. You want to test for the gas, so make sure that you're really positively identifying the gas at the mouth there. So do not insert it into the test tube itself, right? So I'm testing for the gas. There's a lot of solution, that's why it's taking a bit longer. Or probably my solution is not too concentrated. That's probably why. How will give me my ammonia gas? So it's starting to boil now. And my litmus paper actually started to turn a little bit. But I do not want to let it touch the side. So I hope you can see that my litmus paper, there's a bit of gas being given out, and as you can see, the gas being given out has slowly turned my litmus paper blue. Alright, so I hope that's very clear. I'm not touching the inside because I do not want to test for sodium hydroxide. I want to test for, oops, so I closed my Bunsen burner first, that's the important thing. Always be safe. So by not inserting the aluminum foil, I just added sodium hydroxide, and I make sure that the sodium hydroxide was added in excess, and there's a reason for it. Okay, so I'll tell you in a little bit. So first of all, I have confirmed that ammonia is present. I have confirmed ammonia is present just by reacting. Okay, so first add excess NaOH and then heat it. And what do I observe? I smell a pungent gas. So the pungent gas is actually ammonia, but that is not the proper test for ammonia. Instead, what we do is it turns red litmus paper blue. As you can see here, it turned red litmus paper blue. We did not touch the side. We only put it at the mouth of the test tube. When the gas hits the moist red litmus paper, it will turn blue very obviously. Therefore, the gas is ammonia. By the time you look at this, it could have been a picture-in-picture comparison if I can be bothered to edit the video. Otherwise, you're just seeing the screen as it is, as I show you right now. Okay, now how can we ensure that when we add aluminium foil to it, how can I ensure that all of the ammonia comes from the nitrate, not from the ammonium? So I must make sure that I remove all the ammonia that comes from the ammonium before I do the test for nitrate. How can I ensure that? Well, this is a very small test tube. I will ideally be transferring it to a boiling tube, because when I have a boiling tube, then I have a bigger volume. I can afford to heat it a bit longer. Oops, hang on, my boiling tube is not going in. So you want to heat it until, you really must heat it until, so it holds nice and snug there, nice and tightly there. So I want to heat it in excess sodium hydroxide, because I want to make sure that before I add the aluminium foil to it, all the ammonia from the ammonium ions have already been converted to ammonia. Okay, so I need to heat it very strongly until all the ammonia has gone. And of course, you can test for until all the ammonia is gone, because by the time there's no more gas being given off, that means if there's no more gas being given off, that means you can test with the red litmus paper and it will not turn blue, because there's simply no more ammonia from the ammonium ion. Okay, this is actually a very interesting question because it's come out for O-level and IGCSE extended practical, and it's also appeared in an A-level setting before as well. So that's why I cover this question in particular in this tutorial, and it's the highlight of today's tutorial, is to think about the order of doing things. At the moment, I can see gas being given out, but I must continue to heat until no more ammonia is given out, and I can test for it. As I said earlier, if I test with red litmus paper, there will be no more red turning to blue, because all the ammonia from ammonium will be gone by then. So I must keep on doing this until all the ammonia is gone, meaning all the ammonium has undergone the reaction. Then the nitrate anion would have remained in solution, if the nitrate ion remain in solution, then I could then test for the nitrate, and any ammonia that I get afterwards would have come from the nitrate ion reacting with the aluminium itself. Alright? I don't know how long I can wait. Maybe I'll just remove some of the solution, so I have much lesser solution. So I don't want to be heating quite a lot of solution, because one, is dangerous, two, it takes a lot of time. Okay, so I want to keep on heating it until I can be sure that there is no more ammonia given off. Alright, so I should have a litmus paper ready as well. So I need a red litmus paper. I need to moisten it. So keep on heating. So I'm going to test for the gas. Oh no! I still have red lemons turning blue, so that is not a good sign at all. So I do not want that. But it's not turning blue as fast as it should be. So I still get ammonia gas being given off, but not a lot. Okay? As you can see, it doesn't go blue that quickly now. So I'm just trying to get rid of the last bit of ammonia gas there. I can add a bit of sodium hydroxide, because sodium hydroxide is an ionic compound, right? So it doesn't exactly evaporate off. So it's actually the ammonia that is coming off from the reaction of sodium hydroxide with ammonium ion. So I want to keep on heating it until no more ammonia is given off from the ammonium ion, because I am going to test for nitrate with the same solution. So usually for ammonium ion, it's very simple on its own. You just get the ammonia gas, get the test, and you're done. But this thing is special because it is actually asking you to test for the nitrate as well, and making sure that the ammonia from the second test comes from the nitrate, not from the ammonium ion. So let me just... So there's still a bit of gas being given out, but I'm not sure if that's just water or something. Okay, so I'll continue heating it, and then I'll test for the gas again. So I hope you can see there's gas given out, but the red litmus paper is not turning blue anymore. So I guess there's just water. Water evaporates off at 100 degrees Celsius, right? Sorry, they boil off at 100 degrees Celsius. So you can see a bit of steam coming out, but the red litmus paper doesn't turn blue anymore. The red litmus paper does not turn blue anymore because all the ammonium ions, all the NH4 plus have reacted with OH minus to give you NH3. So now I still have my nitrate NO3 minus ion present in here. What do I do next? I test for nitrate, just to reinforce what I said earlier. The test for nitrate is to add aqueous sodium hydroxide, which I already have a lot of sodium hydroxide here because I wanted to get rid of all the ammonia from ammonium earlier, which I did already. I tested until all the ammonia is gone and the red litmus paper doesn't turn blue anymore. So no more ammonia because no more ammonium. Now what do? I need to add aluminium foil. This is aluminium foil. Just add a little bit of it. I think one foil should be enough. Okay. So the aluminium foil on its own doesn't do anything. So we can see the aluminium foil at the bottom. Well, it is kind of floating on top of the solution. So remember my litmus paper, my red litmus paper doesn't turn blue just now because there was no more ammonia. I already have excess sodium hydroxide in there. So all I need to do is, I just need to heat it. So using the blue flame, I will heat it with the aluminium foil inside, and any ammonia gas I get will be a result of, nitrate ion. There you go. You see how the red litmus paper is turned blue? Just now there was no more ammonia given off because all the ammonium ion has reacted, but now I get ammonia given off because I've just added aluminium to the solution, and the aluminium foil together with the remaining nitrate NO3- ion can undergo a further reaction to give you more ammonia, and there's actually so it's pretty pungent smelling. Yeah. So then there's the second test. Oops. So after I fully test for the ammonium ion, I will test for the nitrate ion, and the nitrate ion. Second test, add some aluminium foil. I already have excess sodium hydroxide, then heat it. This was already in excess aqueous sodium hydroxide, and what I get just now was I get a pungent gas again. So pungent gas is formed or is produced. So you don't observe the pungent gas because pungent is to do with smell, and you don't observe a colorless gas. Instead, it turns red litmus paper blue, which I just show you. So you saw it with your own eye. Even if you haven't done this practical before, it's really important that you can appreciate the complexity as well as the dexterity in terms of your hand-eye coordination. What are you looking for? What are you not looking for? A lot of students lost mark in qualitative analysis because they lack details. They think they must know everything, but it's more about, it's called analysis. So you need to be ready to observe and see, and of course smell, and of course you need to know when do you test for this, when do you test for that, and you can't do that if you have to rely on the table all the time. Even if you are provided with a table in a paper 3 or practical setting, it is so impractical if you don't know the test, because they actually ask you in a theory paper as well. Alright, so there's a difficult bit on ammonium nitrate where you need to make sure that the ammonia from the first test comes entirely from ammonium ion, and I have to completely remove all the ammonia by reacting all the NH4 plus completely before I add in the aluminium foil and test for the nitrate ion that still remain in the solution mixture, and therefore the second test confirmed that the ammonia produced will have come from the nitrate and not from the ammonium ion. Okay? So the very last thing, not the very last thing, the second last thing, remember I make up a solution of ammonium chloride as well. So I was going to show you the difference between the ammonium chloride and ammonium nitrate. So ammonium chloride would definitely give you the ammonium ion test, but I just want to show you that when I add aluminium foil, now I can't show you that, because if I'm going to test for nitrate, if I test for nitrate, this is ammonium chloride, yeah? If I test for nitrate straight away, I will have aluminium foil with sodium hydroxide. Sodium hydroxide and aluminium straight away would give me ammonia gas, not because it has nitrate, but because this aluminium will not react. So you will still get the aluminium on its own because there's no nitrate, but you will get sodium hydroxide, and this ammonium chloride will give you an ammonia gas that will turn red litmus paper blue as well. So unless you did exactly what we did with ammonium nitrate, you test for ammonium first, you test for ammonium ion first for this ammonium chloride. Ammonium chloride is NH4Cl, so it's NH4 plus and Cl minus. So you have to test for the ammonium ion first without the aluminium foil, and then you will get ammonia gas. You have to fully react all the ammonium ion, doing what I did earlier, heating until adding in excess NaOH, and heating until no more ammonia is given off, and you can check by seeing the red litmus paper doesn't turn blue anymore when there's no more ammonia being given off. Then you test for nitrate. The test for nitrate second will be negative because there will be no more ammonia given off because there's no nitrate ion in ammonium chloride. And then of course if it's not nitrate, then you can test for other anions like adding acid and whether it's carbonate or not, because I showed you earlier, acid will react with carbonate. You can then test for sulfate by adding things like barium nitrate. So barium nitrate is a colorless solution. barium nitrate, Ba2 plus NO3 minus. So it's Ba bracket NO3 twice. So barium nitrate is a test for sulfate, and it will precipitate out white solid if it is sulfate present. Of course, it was ammonium chloride, and we could do a very quick test with silver nitrate. Oh no, my test tube holder is stuck. I don't want to break the glass. Anyway, I have another test tube holder here, so I hope this one is stable. Yeah, this one is stable enough. This is silver nitrate. You will always see silver nitrate in a dark container like this. Silver nitrate is silver 1 nitrate. Silver 1 is very sensitive to light, so that's why this kind of brown color container prevent it from exposed to white light, which can decompose silver 1 into silver. That's the principle of photography. Well, back then, before we have digital camera, we took photos with those films, okay, and those are actually forming silver precipitate. So as you could see, what happened when I add silver nitrate. So silver nitrate is a is a colorless solution. Silver nitrate is a colorless solution. Don't know if you can see it clearly. So it's colorless. So there's a bit of silver stain there already, being exposed to light. And this was ammonium chloride. They give you a white color precipitate. As you could see, this is a precipitate because you cannot see through. You see on the screen, you cannot see my face because that thing, you cannot see through the test tube into my face because that is a precipitate. That is what you call a precipitate. This is not a white solution. Do not ever write white solution. It's a very common mistake among students. I wouldn't say it's a mistake. It's probably like students are misguided. Learners are confused between what is a solution, which is see-through, it's transparent, you can see through it, versus what is a solid and a precipitate. Okay? Last but not least, I just want to cover this thing which was really, really complicated. But actually it's not that complicated. It's a double salt I talked earlier. It's got 2 salts, ammonium sulfate as well as iron 2 sulfate. Right? So you're testing for 2 cations here, by the way, and it's a bit colored. So let's grab a new spatula. So it was a bit greenish, right? Because of the presence of the transition. Yeah, okay. Bad mistake. Don't spill things everywhere. Okay, but this is just me alone in the lab, and I know my lab safety. So, alright, there are actually other people working in school as well. So if anything ever happens, I can just shout out and they can come to save me. Right? So never ever work in the lab alone because it's dangerous. And you need to be accessible to other people as well. If something happens to you, then other people can come to your rescue straight away. Of course, as usual, glasses. Safety glasses. So I'm not being extremely careful here, but the standard laboratory procedures, safety goggles or safety glasses, and the lab coat is essential. Okay, so I'm not walking the talk here, and it is my bad, it's my mistake. But you should really have a lab coat and a safety glasses on as the formal procedure when working in the lab. Right? So I have a bit of this solid here, and I'll dissolve it in distilled water. Distilled water contains no dissolved ions. This solution doesn't look so clear on the screen, but I can see that it's a little bit pale greenish. I can add a little bit more of the solid if I want to. Maybe I'll add a little bit more of the solid. It's still not very clear on the screen itself, but it's starting to look a bit greeny-ish. So if I just have, so I won't put the spatula back into the thing again because you never put the spatula that has water or that has solution into the container itself. Okay, so I think it's getting clearer on the screen that it's starting to look a bit colored now. So the boiling tube was clean, and now I have a little bit of color solution, not very colored, because remember this is a mixture of ammonium sulfate as well as iron 2 sulfate. Okay, so iron 2 will decompose, it will get oxidized to iron 3 in the presence of water very easily. Okay, that's why we always make out our iron 2 sulfate in acid, because they will slow down the reaction. Anyway, so 2 cations. I will split it into 2 portions. No, actually I split it into multiple portions because I also need to test for the anions as well. So a couple of portions is alright. So 3 portions. I think because I have sulfate, I'll just show you the test for sulfate first of all. So I know the bulk of this tutorial video, I said earlier, was to do with test for ammonium ion. So this is barium nitrate. This was the solution that has the double salt. Colorless solution of barium nitrate. How you can see what happened? So you cannot see my face now, you cannot see my eyes now because you cannot see through it because this is actually a white precipitate. So whenever you have sulfate, so this was ammonium, 2 of them, and you have, what was the other one? Iron 2 plus, and then you have SO4, 3 of them. So this is a double salt. It's actually a combination of, I don't know how many times I've said this, it's a combination of ammonium sulfate and iron 2 sulfate, SO4 2 minus, Fe2 plus. Alright, so it has a sulfate anion. Test for SO4 2 minus is you add aqueous barium chloride. I know I have used barium nitrate because it's either barium chloride or barium nitrate. Both of these are aqueous solution. Aqueous solution because they dissolve in water. Okay, so when they react with the sulfate, what you get is this classic precipitation reaction. Test for sulfate is the formation of a white precipitate when the 2 colorless solution meet together. So what you observe is a white PPT, or white PPT is formed, or white PPT is observed. Alright, so the barium sulfate is the white precipitate, but your observation is what you see. You don't see barium sulfate, you see a white precipitate being formed from the 2 solutions. This is by adding barium nitrate or barium chloride, which is colorless, to a solution that contains sulfate, and therefore you get a white precipitate of barium sulfate. And when you see a white precipitate, when you add barium chloride or barium nitrate, it tells you sulfate is present, SO4 2 minus is present, and because you are adding barium chloride, barium nitrate, so the sulfate must be in the other solution. So the other solution can be concluded to contain SO4 2 minus. That is your conclusion. Alright? Now I'm going to test for the cations. So test for Fe2 plus first. So remember you have 2 cations. You have Fe2 plus and you have NH4 plus. The test for NH4 plus is very standard, just like what I've done throughout the entire video, is to test for ammonium ion. You need to add sodium hydroxide in excess, and then you heat it, and then you get ammonia gas. Alright? But first of all, you also have other cations, and the other cation is iron 2 plus. Iron 2 plus will give you a colored precipitate that is insoluble in excess. Alright? So this is my test tube holder, just making sure that it can hold properly. So this is my solution. I will add sodium hydroxide. Sodium hydroxide is colorless. So what happened? You get some precipitate. My solution was there to start with. I should probably add about this much for it to be equal amount. But I need excess sodium hydroxide afterward to check whether it's soluble or not. Okay? So you should do it drop by drop and then you can see it. But I'm a professional, so I know what I'm doing. So you know what happens here. You get a green precipitate, so like my color of the shirt, but this is a bit darker. Don't forget that green precipitate or dark green precipitate with sodium hydroxide could also mean that it's chromium 3 plus. Okay, so you get a green precipitate. In fact, it's a dirty green precipitate. So this is formed when you add a little bit of it. So you should know that chromium 3 plus give you the same kind of precipitate, but that's why we need to add excess sodium hydroxide. And you don't see the precipitate going away, right? You see the green precipitate remains because the chromium 3 plus hydroxide, when they form chromium 3 hydroxide, it will be soluble in excess sodium hydroxide. But when it's iron 2 hydroxide, it will remain insoluble. That's why you cannot see through my eyes, because this is a precipitate that remain insoluble, that do not dissolve in excess NaOH. Green precipitate is formed insoluble in excess NaOH. Okay, so that is what you see. This is what you write. Okay, so remember that the test for cation, colored species mean it's transition metal. Green color, like my shirt, could mean that it's chromium 3 plus or iron 2 plus. Therefore, you have to add in excess. So you can see the iron 2 has slowly turned brown on top there. So it's very quick, yeah. So iron 2 hydroxide is very, very quickly oxidized. If I leave this standing for about 15 minutes, you will see it turning more and more brown. The brown color is iron 3 hydroxide, and you can smell it. It smells a little bit like rust, because rust is iron 3 oxide, and this is iron 3 hydroxide. The iron 2 hydroxide has been slowly well, not very slow, quite rapidly oxidized to iron 3 plus. I hope you can see the brown coloration on top. Most of it is still iron 2, and don't forget that you still have ammonium ions in here, because you have a double salt. You still have ammonium ions in here that we're going to test right now. Okay. Okay, so I have a boiling tube, so I think I'll probably use a boiling tube, because this thing is really full. It is very dangerous to heat something which is very full. Okay. So I'll just add sodium hydroxide to this. Okay. And I'll add excess sodium hydroxide. As you can see, it's also the precipitate remaining insoluble. But I've added quite a lot of sodium hydroxide. So even though it looks like it's starting to dissolve, but it's not, because it still is not see-through. Okay, you can't see my eyes, right? Because it has a precipitate. It's a precipitate that is insoluble in excess NaOH. So this is not chromium 3. And you can see that the top bit has started to go on a bit browny as well, because of the rapid oxidation of the iron 2 hydroxide to iron 3. So I'm going to test for the ammonium ion, and that's the last thing we'll do in this tutorial video. That's basically what we have done the entire time to test for. Okay, so I have my red litmus paper. I need to moisten it. I need to damp it with a little bit of distilled water. Remember, we are testing the gas. We are testing the gas. We are not testing the sodium hydroxide. So do not let this touch the side. Okay. So let it boil for a bit. So make sure it's completely swirl. Let it boil for a bit, and then test for the gas that's given off. So you should be able to smell the pungent gas if you take a whiff of it, or sometimes you can see a little bit of vapor being given off, because they come off as like that steamy white fumes, alright? So it takes some time, and there's a bit of sound saying that it's starting to go. I'll just wait until it's kind of boiling, and then I'll bring it close to the camera so that you can see what is going on. Okay, so that's kind of boiling, and then this is my red litmus paper. As you can see, I'm not touching the inside. I'm testing the gas. I'm not testing the solution on the inside. This is a red litmus paper turning blue. So it's a moist red litmus paper turning blue. Okay. So I test for ammonium ions. What is this? Add excess NaOH. Heat it, and then a pungent gas is formed. Pungent gas is formed. Pungent meaning quite smelly, yeah, okay, in a bad way, okay, smells like your urine actually. When you go to the toilet, red litmus paper turns blue. That is your observation, and then your conclusion is NH3 gas is present, and you get the NH3 gas as a result of just adding NaOH and heating it. Okay, so that means the previous solution, it contains ammonium ions. Ammonium ion is NH4 plus. Going back to the ionic equation, which is the underlying chemistry behind the displacement of ammonia from ammonium ion using any hydroxide. Could be lime water, which is calcium hydroxide, could be sodium hydroxide, could be any hydroxide. Alright, so that's it from me in this tutorial video. It's getting a bit long now. I've done altogether qualitative analysis, but I try to focus specifically on ammonium ions with a particular interest in this thing called ammonium nitrate, which I made up in my other video as my stock solution. It turned out that the concentration was good enough to test for both ammonium ion and the nitrate ion. Remember that both of them give you ammonia gas, so in order to confirm that I have nitrate ion, I must really fully form all the ammonia. I must really fully reacted all the ammonium ions with sodium hydroxide to get all the ammonia out and test for it with a red litmus paper that doesn't turn blue anymore. Then I add the aluminium foil in order to test for the nitrate, and I get more ammonia because the nitrate and the aluminium reacts together to give me more ammonia, but not from the ammonium because I already fully reacted the ammonium. So that was in the middle of the video just now. I also talk about ammonium chloride and ammonium carbonate. It's the first one we talk about in the tutorial video, and then the other one, the last one that I talk about, is this double salt. This is actually more common in A-level chemistry, but you never know. I mean, it's practically just practical, no pun intended, but it's just practical, and it's not a difference on A-level or O-level. It's just, can you do the practical? Can you think about the ions present? Can you think about the result that you are expecting? And can you analyze the results and make reasonable conclusions from it? Okay, so that's it from me in this tutorial video. Thank you for watching, and if you enjoy my tutorial videos, make sure you browse around the channel. There are a lot more useful things. I just don't have enough time to actually, edit a lot of videos, and not being that professional in video editing because that's not my day job, and my specialty is basically this thinking aloud and going through ideas and teaching students, and that is my specialty. And yeah, if you think I made a mistake somewhere, do let me know. I do make mistakes, such as not wearing a lab coat, such as not wearing safety goggles, but those are standards that you should do in the lab as part of the safety protocol. Yeah, I try to highlight a bit of safety hazards and stuff as I go along, other things as well, but if you think I missed anything, let me know in the comments. And yeah, okay, so don't forget to subscribe to the channel and share the channel widely with all your friends, all your chat groups, study groups, and many other people, and I appreciate you in advance for doing that. Okay, so I'll see you in the next video.